Calculus Lesson A, Example 10, has three different types of problems, and we're going to work all three of them separately in this video. The first thing to remember when doing factorials is, of course, what factorial means. And 14 factorial simply means 14 times 13 times 12 times 11, etc. Now, in this case, you have all of that, 14 factorial, over 6 factorial, which, of course, is 6 times 5 times 4 times 3, etc., times 11 times 10 times 9, etc. Now that can get really confusing and can take up a lot of space. In fact, most calculators can't even calculate these huge numbers that are necessary to solve this problem, so we're going to look at a shortcut method. So if you're looking at this problem, 14 factorial over 6 factorial, 11 factorial, I like to go ahead and just try to cancel something out. And what I notice is that there's a 14 factorial and a number just slightly smaller than it in the denominator, 11 factorial, which means the numerator, if we wrote it out, would be 14 times 13 times 12 times 11 factorial. In other words, we would say 11 times 10 times 9, which is the same as 11 factorial. So the denominator would be 6 factorial times 11 factorial. And here's the key. The key is that we can cancel these out, because 11 factorial cancels out with 11 factorial, leaving us with a much smaller problem. But it doesn't stop there. We can continue canceling out if we go ahead and write out 6 factorial. Now you'll notice that 6 and 2 multiply to equal 12. So that took care of that for us. We don't have anything that will multiply to equal 13 or 14 in the denominator, but I think you will agree that 14 times 13 over 5 times 4 times 3 is a lot simpler. Notice I left out the 1 because it really doesn't matter. From here, you can just punch those numbers in your calculator and get an answer. The B problem is a summation problem. And you may remember from last year that sigma, the capital sigma, always means summation. And it means you're going to plug in all of the integers from j equals 0 up till j equals 3 into the function that they give. So we need to go ahead and punch in 0 first. So we're going to say 2 to the 0th over 0 plus 1. Now anything raised to the 0th power is of course 1, so this equals 1 over 1, and of course the answer to that will be 1. Now it's called a summation problem because we are going to add all of these answers up. So that's the first one. That's plugging in 1. Now we're moving up from 0 all the way to 3. So now we punch in 1. So we say 2 to the 1 over 1 plus 1. Well, 2 to the 1 is 2, and 1 plus 1 is 2. So we have 2 over 2, which of course equals 1. So if we punch in j equals 0, we get 1. We punch in j equals 1, we get 1. Now don't get too used to that pattern because we got to continue on. Let's punch in 2 now. So 2 to the 2, anywhere we see a j, we punch it in, and then 2 plus 1. So that's 4 over 3. Moving to our last one is 3, so we're going to say 2 cubed over 3 plus 1. Of course, 2 cubed is 8, and that's over 4. We can go ahead and simplify that down to 2 to make it easier. And now we just add all of those numbers up, and we have the answer to our summation problem. Once again, the capital sigma always means summation, and you take the number they give you at the bottom, plug it in for what they mean to, for what they say to, and go all the way up, just going using the integers 1, 2, 3, until you get to the last number, and then add all of those answers up. This last summation example is a bit of a trick problem because it says to punch in 1 for I. Well, if you think about it, there is no I in the actual function. So when I equals 1, what does 3 equal? Well, the answer is 3. So when I equals 1, this particular function will equal 3. All right, but we still have to go up to the next one. What about when I equals 2? What does 3 equal when I equals 2? Well, it once again still just equals 3. When I equals 3, 3 still equals 3, and then when I equals 4, well, 3 still equals 3. The key is, all this problem is doing is telling us to add 3 4 times, and so our answer will be 12. Once again, it's a little bit of a trick problem because the variable that they're telling you to punch in for is not actually in the function. But you still have to add it that many times just as if it were.